What's up, everybody, and welcome back to another video from the Scalar Learning channel. And today we are back on SAT Math, but in particular, we are doing the May 2021 International SAT, which everybody has been requesting. So I'm super excited. It has been officially released by the College Board, which is why I'm able to do it. And that is it. We are taking it, if you're new to the channel, we are taking it for the first time in real time, which means this is an authentic test-taking experience, and I'm doing it under time conditions. But of course, I will still be explaining the questions as I go along, still within that 25 minutes. All right, here we go, ladies and gentlemen. No calculator, my favorite section. We're going to start in 3, 2, 1. Let's do it. All right, a college mathematics department plans to spend $1,800 buying computers and books. Each computer costs $300 and each book costs $90. Which equation represents a situation where X is the number of computers, Y is the number of books, and it's these two, and it plans to spend exactly $1,800. There's my equation. 300X plus 90Y equals 1,800. Boom, done. Just make sure I didn't make any mistakes. Each computer costs 300. X is the number of computers. Nailed it. All right, number 2. What is the x-intercept of the... Okay, it's talking about x-intercept. So the nice way to do this one is you notice if you have a graph, the x-intercept is where it's hitting the x-axis, meaning the y value is 0. So all you got to do is plug 0 in for y. That becomes 8x equals 6 times 0 is, of course, 0 equals 24. Isolate, divide both sides by 8, and x equals 3. So my x-intercept is 3, 0. They also notice that they give you only possibilities for x-intercepts where all the y's are correctly 0. But yeah, you plug 0 in here, you plug 3 in here, you know it works. All the other ones will not. Okay, number 3. What system of linear equations is represented by the lines shown? First of all, let's see if we can figure out what their slopes are. Looks like the slopes are up 3 over 2. So slope of 3 over 2. Make this a little thinner. Okay, so which ones? Oh, and they're not in slope-intercept form. They're in standard form. Okay, here's what I'm gonna do. I'm gonna get both of these equations based on y equals mx plus b, and then I'm gonna convert them. So let me see. Yeah, that's pretty good. Okay, so this one has a y-intercept of -3, so it's y equals 3 over 2, x minus 3. The bottom one is y equals 3 over 2x minus 6. And these are all in standard form, which basically just means we get the x and y together and then make sure there's no fraction coefficients. So this would be -3 over 2, and the x term has to be positive. -3 over 2x plus y equals -6. -3 over 2x plus y equals -3. Let's erase this. Multiply top and bottom, multiply both of these guys by -2. So it's become 3x minus 2y equals +6. This one becomes 3x. Again, I'm multiplying by -2, right? -2 times that is -2y, and -2 times that is +12. So there's my two answers in standard form. 3x minus 2y equals 6. And it's the top one. Look at that. 3x minus 2y equals 6, 3x plus 2y. Yeah, see, these wouldn't even make sense. I didn't bother to look at them, but I could have if I wanted to. But I know that these are all going to have different slopes because you see the coefficients are different, positive, -2 versus +2 in front of the y, so on and so forth. So those will not give equivalent slopes. So I could have done it much more quickly, but that is kind of like the standard way to do it. Here we go, number 4. The given equation relates the positive numbers a, b, k, n, which is the following correctly expresses A. Okay, so isolate A, and that's all they've done, isolating quantities. So first I'm going to say KA equals 10 minus NB. Then I'm going to divide both sides by K, boom, and we've got A equals 10 minus NB over K, boom, done. Number 5. The function F models Jack's pulse in beats per minute as a function of his speed in kilometers per hour on a stationary bicycle. So hold on. BPM, so as the speed increases, of course, the BPM, beats per minute, increases. That makes sense. Based on the model, what was Jack's pulse? What was Jack's pulse that's on here when his speed was 0? Right here. It's basically the y-intercept, which is 63. Notice before I started answering the question or going in too much, I really tried to get my head around the graph, and I do think that's important. It doesn't take that long to maybe like 10 seconds, 15 seconds, but I do think that's important. Number 6. Triangle DEF not shown is similar. Well, let's draw it out then. Yeah, it's here. Let's do it like this. Let's not do it in red. And the only thing I don't like about this whiteboard, you see it takes a little longer to kind of draw out a triangle. All right, so similar, obviously it's proportionate. So DEF is similar to ABC. So the D is in the same spot as the A, because, right, it's the same order. E is the B, and then F like this, where DE corresponds to side AB. And see, I got it all set up like that. That means angle E is 37 as well, by the way. And DE corresponds to AB, DF corresponds to AC, and DE equals 2AB. So this is actually bigger. So I drew it kind of not the right way, but it's all good. So if this is X, so DE equals 2 of those. You get what I'm saying? So this is actually double this. What is the measure of angle DFE? Okay, the side length doesn't matter. And here's why. Because when triangles are similar, their angles are equal. So if that's 37, this is 53. So is this one. So it doesn't matter. DFE is just 53 degrees. And they put the 106 to trick you that you're like, oh, I should double the angle. Doesn't matter. Similar triangles, angles are all equal. All right, which expression is equivalent to this? What are they doing? They're factoring. So this looks nicely factorable. Let's do it. It becomes x squared, and then what multiplies to 81 adds to negative 18? It's negative 9, right? And that's a nice perfect square, but these are differences of, oh, actually, let's make it x squared. Yeah, let's keep it like this. And then we're going to factor each of these difference of squares like separately, because when I say difference of squares, this is a perfect square, that's a perfect square, you're subtracting. So you take the square root of each, and then it's plus minus. So x minus 3, x plus 3, x minus 3, x plus 3. And then, since these are the same and these are the same, you can group them together and make it x minus 3 squared times x plus 3 squared. And it's this guy. Just trying to make sure I didn't make any mistakes. X squared minus 9, x squared minus 9. X minus 3, x plus 3, x minus 3, x. Yeah, we're good to go. Numero 8. Which expression is equivalent to this? Where G. Okay, notice what they're doing. They're going from rational exponents to the radical version. And it looks like, okay, so the nice thing is, you're taking the fifth root of both of them. So I can kind of group these guys, the fifth root of E. Actually, here, let me, I got a better way. It'll make more sense. So I can say G to the fourth, H to the second, because the numerators are the powers. And then but we can treat it just like fraction multiplication. This is to the 1/5 power. See, if I was to redistribute, that'd be 2/5, that'd be 4/5. Then the fifth root, since they have in radical form, that's the same, or sorry, to the 1/5 power, that's the same as the fifth root. G4, H squared. That's the winner, and we're done. Number 9. Number 9, what is an equation of the graph shown? I know it's exponential. Okay, we're going to plug and chug. So first of all, when x equals 1, this is 2, 4, 6. When we should have 1, 6, and 0, 2. Those are 2 coordinates. That should be more than enough. This gives me 0, 1, you're out. This gives me 0, 2. This does give me 1, 6. Is probably the answer. This one gives me 0, 1, you're out. This one gives me 0, if I plug it, because remember, anything to the 0th power is 1. So 2 to the 0th power is 1 times 3 is 3, not 2 like I'm supposed to be getting. And just double check one more point. If I plug in 2, do I get 18? 3 squared is 9 times 2 is 18. Boom, done. Numero 10. What is the solution to the given equaciones? If you want to plug and chug, you can. Yeah, let's plug and chug. Why not? So -6 definitely doesn't work. -3 gives you 1. Nope. 3 gives me 5 and 5. This is the winner. And then 6 would give me 8 and 2. All right, now let me explain a little bit why. So 3 plus 2 equals 3 minus 8. 3 plus 2 is 5. 3 minus 8 is -5. Well, absolute value is the positive purifier. Absolute value of 5 is 5. Absolute value of -5 is 5. It's true. It's a solution. Done. 11. The equation above can be represented by a parabola in the xy plane. The parabola is then translated. Hold on. The current vertex. Okay. First of all, the current vertex is at -5. It's whatever's the opposite of this, comma -8. Okay. Then we're translating it so that the vertex goes to 0, 0. So we're going from here to 0, 0. Which of the following best describes the translation? So check it out. It's got to go to the right by 5. If I could kind of draw this out so you have an idea of what I'm talking about. Let's say this is -8 and this is -5, right? If here's the vertex. So you have to go up by 8 and across by 5. So it should be, it doesn't say up, it says, okay. So 5 units, like we said, in the positive direction for X. No, that's wrong. 5 units in the positive direction, 8 units in the positive direction for Y. That's the winner. But positive direction is up. They just said positive direction, whatever. And then 5 to the right is 5 units in the positive direction of X. And let me just make sure I didn't make a mistake. 5 units in the positive direction, -5, -8. Okay, we're good to go. Number 12. Which of the following statement is true about the equation above? Okay. Before I look at the answer choices, the mistake would be to just start looking at the answer choices and be like, I wonder which one. No, what they really want us to do here is simplify first, then we can analyze more. 5x plus 3x is 8x. See, I'm just combining like terms. Equals, let's distribute. 3x, right? Distribute. 3x plus 12 plus 5x minus 10. Good. Like terms. Let's combine. 8x minus 2 equals 8x plus 2. How nice. These cancel out. Look what I got. I got -2 equals 2. Now I know that this equation has no solution because I got an absurd answer. The equation had nope. Winner. Equation has no solution, and we're good to go. Number 13. The graph of the function f defined by this is shown. Okay. That means the vertex, I'm just going to put this in. Sometimes I like to do that. The vertex is at -4, because remember, it's the opposite of that. -5. That's cool. That's helpful. Graph passes through the points -10a and a b, where in your constants, what is the value of b? Okay. This is, I didn't need that center. This is just a straight plug and chug operation, because whenever they give us a coordinate like this, look, this is my y value, aka the function value, so let's plug it in. A equals 1/4, and in this case, the corresponding x value is -10. -10 plus 4 squared minus 5. So this becomes -6 squared minus 5. Don't forget the 1/4. That becomes 36, 1/4 of 36. We gotta be extra careful here because there's no calculator, so make sure not to make any mistakes. 1/4 of 36 is 9 minus 5 equals a. That means a equals 4. Okay, great. So this value is 4, and then they want a comma b. So now I take the same original function again, and I plug 4 into it, the a value, because I already know a is 4. So 4 plus 4, so 1/4 of 4 plus 4 squared minus 5. It's, of course, 1/4 of 8 squared is 64. 1/4 of 64 is 16, right? 16. And then 16 minus 5 is 11. So my b value is 11. They also have the a value here, so let's see, it's pretty sneaky. Let me just make sure. I'm going to do mentally real quick double check because it's a complicated question. 36, 9, 4. So a is 4. 4 over here, and I'm getting 11. And yeah, I guess it kind of all looks right, so we're happy. Circle 11. All right, 14, 11 minutes, 12 minutes to go. Which of the following is the solution to a given equation? Okay, obviously, these answer choices, I know it's a quadratic. I wish it would factorable, but I'm pretty sure it's not. We're going to have to use the quadratic formula. So let's go with it. Negative b, hold on. A is 1, b is -12, c is 23. Negative b plus or minus square root of b squared. That's, yeah, I'll write it out. -12 squared minus 4a, and then c is 23 over 2 times a, which is 2 times 1, which is 2. 12 plus or minus square root, and these are all the positive versions, doesn't matter. That becomes 144 minus 80, 92 over 2. 144 minus 92 is 8 and 52, right? 52. 8 and then 44. It is 52, yeah? Yeah. 12 plus or minus square root of 52 over 2. Simplify that radical. That's 4 times 13, so I can take the square root of 4, pull that out. That's 2 rad 13. And now I can divide everything by 2, and it's 6 plus or minus rad 13, and that's the winner. I could have eliminated C and A because I know that negative B is going to be a positive, but it's all good. 15. I'm kind of old school on those ones. I just like to do it the pure way. X, Y plane points blank and blank are endpoints of a diameter of a circle. Let's draw out a circle just to visualize it, as I always say. We've got here is negative 310. Here is 310. Which equation represents this circle? Okay, first things first, we got to find the center, because the center will be like here and here, assuming those are correct. How do I find the center if I know that these are the endpoints of the diameter? Well, isn't it true that the center will be right in the middle of that? And since it's both at 10, we're chilling there, but I can use the midpoint formula or just common sense. What's right in between negative 3 and 3? 0. What's right in between 10 and 10? Well, 10, same height. So there is my center, 0, 10. And in the formula, it's always x minus h, which is the x value of the center, y, and that's going to be 0 here. And my k value is 10. So it's x minus 0, aka x squared, which has got to be this one. And then y minus 10 is correct. Yeah, it has to be a, but we're going to verify anyways. On this side needs to be the radius squared. Well, isn't this radius 3, right? Because from 0 to 3 is a distance of 3. 3 squared is 9. Boom, done. Double verified. Let us go to number 16. Free response, 9 minutes to go. The solution to the given equations is xy. What is the value of x? All right. I am solving for x, so let's get rid of the y's. So I'm going to multiply the bottom one by 3, the top one by 2. So we got 4x plus 6y equals 4. I always double check that I didn't mess up the distribution. I've done that in the past. 3x minus 6y equals 24. Combine, kill those guys. That's 7x equals 24 plus 4 is 28. Divide both sides by 7x equals 4. I like that it's a whole number, but I'm going to double check. 4 minus, okay, and y has to be negative 2. I'm just going to write this down just so I can double check, because 4 minus 2 times negative 2 is 8, right? Now, if it works up here, we know we're good to go. 4 times 2 is 8, plus 3 times negative 2 is negative 6. 8 minus 6 is indeed 2. Boom, done. 17, what value of n satisfies the equation here? Wow, this is interesting. It's not too hard. Subtract a 9n from both sides. 3 equals 6n, right? 15n minus 9, 15 minus 9 is 6. So there you go. Divide both sides by 6. And we've got n equals 3/6, or 1/2 is what I'll reduce it to. Man, that is just seems bizarrely easy for a 17, but it is. I'm going to double check. Plug it in. 4.5 plus 3 is 7.5. Half of 15 is 7.5. Boom, done. The function f is defined by this. For what value of f of x? For what value of x does f of x equal 30? Plug and chug. 30, it replaces the function value equals 2/5 x plus 10, and then we solve for x. Subtract 10 from both sides. 20 equals 2/5 x. Now to get rid of the 2/5, multiply by the reciprocal. Why do we do that? Because 2/5 times 5 over 2 is 1. Thereby, it eliminates it, right? If you don't believe me, multiply it, multiply it. It gets 10 over 10. That's 1. 1x is just x. What is 5 halves of 20? We can divide by 2 first. That's 10 times 5 is 50. And there's the answer. Now we're going to double check. Plug in 50. 2/5 of 50 is indeed 20. 20 plus 10 is 30. Boom, done. Numero 19. An office building has a room with a square-shaped floor. Let's draw that out. The actual, wait, what? The actual length of the floor, and then we got a blueprint. Okay. So the actual length of the floor is 90 times the blueprint. The actual area of the floor is P times the area from the blueprint. What is the value of P? All right, I think I know it, but I'm going to show you step by step. So this one has an area of x squared because it's a square, right? x times x is x squared. This is a square as well. What's the area of the real deal relative to this guy in terms of x? Well, what's 90 times 90? Well, instead, what's 9 times 9? 81. And then just add the two zeros. There we go. And they say, now we say the actual, watch how I turn this into an equation. The actual area, which is this, of the floor is, that's my equal sign, P times the area of the blueprint. What is P? Now there is no question. You might have already said like, hey, it's probably 8,100. Now there's no question that I'm doing it right because I set up an equation explicitly based on what the language is of the problem. Divide both sides by x squared, cancel, and guess what? P equals 8,100. Number 20, the graph of y equals blah, 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 where a and c are constant. And we got 5 minutes, so we're golden, is shown. What's the value of a? Okay, first of all, C is 2. Because if I plug in 0, I get 2. To get A, I can plug in another plug-in chunk. I'll plug in any other point. 3 for Y equals A times 2 for X. That's the corresponding Y value, plus 2. 3 equals 4A plus 2. 1, subtract 2 from both sides. 1 equals 4a, divide by 4, and a equals 1/4. But I'm going to verify it anyways. So I know my full function as I've defined it is this now. So I should be able to plug in all these points and we should be good to go. If I plug in 4, that's 16. 1/4 of 16 is 4 plus 2 is 6. Boom, done. If I plug in 3, which we're already done, but whatever, I get, 2, whatever, I get 4 times 1/4 is 1 plus 2 is 3. Plug in 0, we know we're good. -2 and -4 are going to be the same results because we're squaring a negative, so it still becomes a positive. Okay, I'm satisfied. We are good to go. Let's see how we did. Now, of course, if you have extra time on the real exam, you're not going to just pause midway. You're going to keep going and, you're not going to chill. You're going to check, double check, triple check, whatever you want over and over. Use that time. But I'm just doing it for you guys, so it's all good. And if I do happen to get something wrong, we shall review it. All right, here we go. International. And if I were to compare this to the US one that I solved last week, I will say, I don't always say this, I know people are always like, man, international is so much harder. I don't actually agree with that. But this one, in the no calculator, I felt is a touch harder than the US. And then I'll see what I see on the calculator section. All right, AAAD. Oops, let's make this thicker. AAAD. Excellent. Let's check out number 5. CBDB. CBDB. Number 9 is BCDD. BCDD. So far, so good. 13, 14, 15. CDA. CDA. Excellent. All right. Now we just got to make sure the free response is good to go. First, we got 4. Yes. Do they say 1/2 or 0.5? Yes. 50. Amazing. 8,100. Yes. And 1/4 for the win. Perfect. And the 8,100 was a little bit like, man, that's such a big number, but it can be 4 digits like that. It's just I don't see it so often. So I was like, I'm pretty sure it's good, but you never know. That is it, guys. And if you guys have additional questions or comments, please make sure to leave them in the comment section below. If you are taking this next SAT in June, I wish you guys all the best of luck, and we will be doing the calculator section next. Thank you guys, as always, for joining. Thank you for all the likes and the support. I can't tell you how much I appreciate it, as now we're at 33,000 subscribers and growing. It's so incredible. And I can't thank you guys enough. This is so fun for me, and I love being able to show you guys how to break this stuff down. So that's it. I'll see you in the next video. Take it easy.